It didn't announce itself. There was no alarm, no spike in the data, no urgency. Just one clean signal, appearing briefly in a river of cosmic noise, then dissolving back into silence as if nothing had happened. At first, nobody stopped scrolling. Deep space is saturated with weak signals that do not matter. Most of them never will. Astronomers are trained to ignore nearly everything they see. If they didn't, every observation would collapse under interference, artifacts, and meaningless fluctuations. Filtering isn't optional. It's survival. So this signal passed through unnoticed, until it came back. Not immediately, not randomly. It returned after a pause. Same frequency, same shape, those same sharp, disciplined edges. That was the first shift. Not excitement, attention. One detection is a ghost. Two can still be coincidence. Even three aren't proof. But repetition with restraint changes the rules. It forces hesitation. Someone stops deleting files automatically. Someone highlights a timestamp. Someone adds a note instead of closing the window. This signal earned that pause. Over the next observation cycles, it appeared again, quietly, reliably. The spacing between its arrivals wasn't perfect, but it was consistent enough to define windows, not guesses, windows. If the instruments were pointed at the right coordinates during those windows, the signal was there. If they weren't, it was missed entirely. That alone was unusual. Most deep space signals don't allow that kind of planning. They flare once and vanish, or they drift unpredictably, or they decay into noise. This one behaved differently. It followed constraints. Same bandwidth, same duration. A slight frequency drift that matched known interstellar effects perfectly. Nothing flashy, nothing evolving. Just order. And order does something dangerous to scientists. It builds expectation. Astronomers stopped passively scanning for the signal. They began to wait for it. That sounds like a small distinction. It isn't. Waiting means the signal crossed a psychological line. It moved from anomaly to source, from random noise to something stable enough to trust. For months, that trust held. Every arrival reinforced the same quiet conclusion: a stable emitter, a stable path, stable behavior. The signal didn't escalate. It didn't respond to observation. It didn't grow more complex. It arrived, behaved exactly as expected, and disappeared again. Until one cycle didn't. The next pulse arrived early. Not by milliseconds, not by rounding error, by enough to break the math cleanly. The arrival time no longer fit the dispersion curve that had held perfectly before. Dispersion isn't guesswork, it's physics. It tells you how much ionized material the signal passed through on its journey to Earth. Change that timing, and you change the entire story of the signal's path through space. The first reaction wasn't alarm. It was denial. Equipment fails. Clocks drift. Software lies. Humans mislabel files. Science protects itself from embarrassment by exhausting every boring explanation first. Calibration was rechecked. Time standards were verified. Pipelines were rerun. Independent confirmations were requested. None of those explanations survived. Then another detail surfaced. The frequency profile had shifted. Not dramatically. Not enough to erase the signal's identity, but enough that it could not be ignored. A subtle change layered onto a familiar structure. That's when the discomfort set in, because now, two independent parameters had changed at the same time: timing and frequency. But other parameters hadn't moved at all. The sky position remained fixed within measurement limits. The overall shape of the signal was still recognizably the same. That combination should not exist. If the path through space had changed, the apparent source position should have shifted. It didn't. If the source itself had changed state, the structure should have distorted more violently. It didn't. If it was interference, it wouldn't have behaved perfectly for so long before failing once. One detail didn't fit, and a single detail that refuses to fit is more dangerous than a dozen that do. Then came the silence. After that broken pulse, the signal never returned. At first, that didn't feel meaningful. Signals disappear constantly. Sources shut down. Observation conditions change. Silence is the default state of the universe. But context is everything. This wasn't a lucky catch. This wasn't a one-time event. This was a signal that had trained its observers to expect it. And after violating its own pattern exactly once, it vanished completely. Targeted monitoring followed. Longer observation windows, coordinated schedules. Multiple instruments across continents pointed at the same empty coordinates. Days passed, then weeks, then months. Nothing. The silence stopped being absence. It became data. Because now the sequence mattered. Repeat, repeat, repeat. Break once, disappear. That isn't clean randomness, and it isn't clean stability either. It sits in a narrow, uncomfortable zone where easy explanations thin out quickly. So, scientists did what they always do next. They ranked possibilities. The most likely explanation is also the least satisfying: a transient medium between Earth and the source, something like a moving pocket of plasma. Plasma can bend radio waves like a lens. It can shift arrival times. It can alter frequencies without touching the source itself. If such a structure crossed the line of sight exactly once, it could explain the early arrival and the frequency shift. Once it dispersed, the effect would vanish. That explanation fits the single anomaly. It fits the lack of recurrence. It doesn't require rewriting physics. And that's why many researchers lean toward it. But it leaves questions behind. Plasma distortions strong enough to cause that deviation are rare. Catching one perfectly aligned exactly once is rarer still. And it doesn't explain why the signal stopped entirely instead of returning to its old reliable behavior. So there's a second explanation. The source itself may have changed. Some extreme objects don't evolve smoothly. They store stress. They release it suddenly. Their rotation can glitch. Their emission geometry can snap into a new configuration. These events can be instantaneous, one-time changes that never repeat. That would explain the clean repetition followed by a single deviation. And it would explain the silence. The source didn't move. It didn't get blocked. It fundamentally changed. Still rare. Still uncomfortable, but plausible. Then there's the third possibility, the one nobody can properly test yet, that this signal belongs to a category we don't fully understand, a type of source where repetition is temporary, where stability isn't a permanent property, but a phase. In that case, the broken pulse wasn't an error, it was a transition. This remains theory, not because it's dramatic, but because there is no confirming data. What scientists mostly agree on is simpler. This signal did not carry encoded information. It did not escalate in complexity. It did not respond to being observed. There was no sign of intention, no dialogue, no progression, just order, followed by a single failure, followed by silence. And that is why this signal still matters. Not because it promised answers, not because it was loud, but because it earned trust. And trust, once earned, rewrites the rules of observation. When something reliable breaks its own pattern, you don't just notice the change, you question everything that came before it. Was it always this fragile? Was the consistency itself misleading? Were the assumptions built on top of it wrong from the beginning? That is what this signal forced astronomers to confront. Not what did we see, but what were we so sure would always stay true? Until the signal returns, if it ever does, that question remains open. And in science, the questions that stay open are often more valuable than the answers we rush to close. The next video looks at 3 other deep space signals that followed patterns just as clean and broke them only once. But unlike this one, the timing of their breaks may not have been random at all.